Hello everyone. This is Tao, a standard engineer from ZDE. Well, I have been working on the 3GPP and now MBS working item for the past few years as a 3GPP delegate. So I believe I can share something from the standard perspective. And this is the content of the speech we are going to talk about. Firstly, I'd like to go briefly through the evolution of cellular broadcast. And then I'll try to spend more time on the second part to tell why MBS in the 5G era can make a difference. And then I will end the speech by sharing ZTE's contribution to the industry. Okay. Well, you might be surprised by this picture that 3GPP actually has been developing the standard, the so-called cellular broadcast standard, for more than 10 years since the second release of LTE in release 9. I guess we really had a high hope for this technique. Therefore, we spent so much efforts on this scenario or this technique. So the first release to support broadcast in LTE was right here. It was around 2010. So at the beginning, our operators like telecom operators wanted us to be able to watch TV on your phone. Sorry, watch TV on your phone. They wanted to compete with those broadcasters like all those standard groups. And you can see there is something called MBS-FM or single frequency network, which is borrowed from traditional TV broadcasting technique. And then later new services like mission critical push to talk, all those new services were emerging. So basically, we want to broadcast services in a smaller region, in a smaller but dynamic area. And in release 16, we are seeing broadcasters, I mean, real broadcasters, not telecom broadcasting, but broadcasters like EBU or BBC or even ABS in China, joining the ecosystem of 3GPP. They also wanted to benefit from the 3GPP ecosystem because everyone has got a phone on your hand, right? So the idea was, what if you can receive on your phone the TV signals from the legacy broadcasting towers? So although the ideas from 10 years ago, you watch TV on your phone, you watch those videos, live broadcasting, you receive those mission critical services and also even V2X IoT services. Although the ideas and the intention was good, the 3GPP is always open to welcome whoever wants to contribute and wants to be part of the ecosystem. But none of this, I can say, unfortunately, none of this really took off. So people might be losing their patience and confidence. This might be the reason why we are only having MBS support in 5G era, only in the third release of 5G. So this is where we are. And now we're heading to release 18 with some kind of enhancements to the release 17 and MBS. So what I want to tell in this page is it's really took us a long time to get where we are now here. And the driving forces behind it is really diverse. And we have operators, and then we have broadcasters, and then we also have verticals like MCPTT, V2X, IoT. And since the scenarios are drastically different through the development, we are seeing two different diverging paths. The first one is large-scale broadcast, which is met by the release 16 technique. And also, we are having the second path, which is the dynamic multicast, which is what we are focusing in release 17. So before we dive into the techniques, details of 5G MBS, I want to firstly to talk about the lessons we have learned from the past. Okay, it seems everyone is making a confession here. Ericsson just gave a few lessons we have learned, but what I'm showing here is more about the requirement part and also the standard part. So I want to focus on the non-technical issues first. My first observation is we might not be at the right timing when we are rolling out the LTE broadcast. As you can see from these two pictures, they are both from Ericsson. I'm a big fan of Ericsson's mobility report. I usually refer to that constantly. So as you can see from the first picture, around 2010, actually the live and scheduled linear viewing or the TV program is the market of which is really shrinking, and on-demand viewing is growing. I mean, on-demand viewing by unicast. And also this picture shows the data traffic of LTE. As you can see, during the debut of LTE, the data traffic runs on LTE is growing exponentially, and around 2010 is just at the beginning. So if we can look back, we can see that the live or the TV program is not really the right requirement or scenario for LTE broadcast. And the second issue I want to address here is the broadcast itself. It is really hard. The ecosystem, the efforts to start to grow the ecosystem is really hard. However, I want to address this issue in later slides, and let us spend some time on those technical issues. Okay, in LTE, there is only if we can have a look at the network capabilities, there is only something called broadcast. There's nothing called multicast. Although the service at the service layer, you can still run multicast services over there, but broadcast service in air interface means there's no feedback, there's no reliability support. What is worse is you have to pre-configure in which area you're going to broadcast. So this means the supported service is going to be quite limited, basically only for TV program. And in LTE, we have a totally separate network architecture to support the MBS or eMMS. Everything is separated. Everything is in a different architecture. So either in core network or RAN, they are even a series of new network interfaces. As for the radio resources, the granularity the operators can utilize is really huge. So when the new services like MCPTT or V2X are emerging, we have to invent another dynamic barrier type, which is called SCPDM in later releases. Actually, in release 13, a few years later. Another issue we had was if 3GPP wants anyone to use certain feature from 3GPP, you need to make it open, make it usable by opening the interface. But the interface open to the application function, there are two interfaces, will only open 10 years later after MBMS was born. It's just too late. So to conclude, the major flaws I can observe from the legacy technique is it was not simply designed with future-proof in mind. In this table, okay, we are moving to the next slide. In this table, I want to compare and to tell why 5G MBS is doing its right. It's doing almost everything right. From every single perspective we have just mentioned for LTE. So firstly, for 5G MBS, it offers the network capability called multicast, other than broadcast. So compared to broadcast, this feature provides the reliability and on-demand P2M or point-to multi-point delivery feature that is missing for broadcast. So for broadcast, it is only point to multi-point transmission on the air interface. But for multicast, the network can decide to use point-to-point, which is exactly the same as unicast. And for P2M, when network think it is needed or efficient. So in the worst case, even UE or network does not support P2M transmission or P2M reception, the network can still offer the multicast services. And second thing is the whole architecture is integrated. So by simply using software upgrades, we can enable that 5G core and also the GNOB to run the multicast services. And also during the standards process, we try to limit the UE complexity in mind. We try to limit everything to align the UE capability to be the same as the legacy UE or the release 15 UE, which means it is possible if I mean, theoretically, it is possible to upgrade UEs or networks to enable such feature. As for the radio resources, compared to the semi-static in later releases, dynamic, for 5G MPS is fully dynamic. And for the open interfaces, okay, as we have said before, for LTE, the interfaces it's only open 10 years later, but hopefully for 5G MPS, by utilizing the, 5G is designed to expose 5G itself is famous for its network capability exposure. So how about the applications? I think I don't need to mention that as Migu, our colleagues from Migu and also colleagues from Ericsson has made a lot of examples about how whatever new applications or old applications. So how about the last question? Broadcast itself is still hard. We are still having the ecosystem problem. So our understanding is 5G MPS in design is making a difference, is offering us an opportunity. So one of the reasons why broadcast itself is hard to take off is because you need to have everything from the 5G core GNOB UE API, application layer, everything to be ready to run. But for multicast, everything here, so in this part, 5G core GNOB UE is almost ready. It's almost ready at the beginning because everything is growing from this part, from the legacy. It's not a separate system. It's an integrated system. And so what we need to do is to focus more on the API part and also the application layer part. So if I can be more ambitious, I'd like to suggest operators to eat the food dog. Sorry, the dog food first by experimenting 5G MPS on their own content applications like Migu from SimCC. And as far as I know, a lot of operators nowadays have their own content source like ADT or Verizon. They all have their own content. And I'm glad to hear a song from Migu that another Migu strength is knowing how to take advantage of the network capability. I think this is a positive signal for 5G multicast. So for those operators with content, in the first step, my suggestion is, what if you can use 5G multicast as a tool to save the operating cost by utilizing the broadcast nature in the air interface? And the second step will be using this feature to make money. So you save the cost first, and then you make money later. So by extending the applications to other areas we have mentioned before. Okay. So at the end of the speech, I'd like to introduce CDE's efforts to make the broadcast or an RMBS a reality. We have been conducting numerous trials with operators and LDT tests with our industrial partners during the past decade. And our latest field demo was with CBN in Beijing, even before the standard was frozen in 2020 and 2021. And we will be continuing our partnership with the major operators in the future. And also ZTE, as one of the few vendors who is able to offer the end-to-end solution from 5G core to run to UE and to what is running on the UE, yeah, this is what we are capable of, and this is basically all about my speech. Your questions and suggestions are welcome. Thank you.
Thank you very much. You have given a very great vision for 5G MPS. Okay, is there any questions?
Yes, can I ask a question to Mr.
Qi? Sure.
Okay, maybe lady first.
Okay.
Okay, thank you. So, hello, Mr. Qi. Thank you for your speech. And I have a small question. So what do you think are the challenges faced in the full adoptions of 5G multicast? Because I believe you have mentioned the difficulties of the 5G broadcast in your presentation, but I didn't see much about the multicast. About the difficulties of the multicast deployment. I mean,
well, actually, I'm focusing more on the multicast part, and I personally am more positive on the multicast part. So I think the challenges still lies in the growing of the ecosystem. I think just like 5G and the wireless infrastructure, I think the road is ready. And for MBS, especially the multicast part here, the network, I believe, is already ready from the 5G core to UE. And now all we need to do is to attract people to see the value, to use it, and to develop applications for it, and to really benefit from it. So compared to LTE broadcast, I'm feeling more positive about 5G multicast. As I've mentioned, it is ready from the beginning in the existing network. All we need to do is a simple, maybe more than simple from engineering perspective, but I think from standard perspective, it's more mature. It's more than the LTE broadcast compared to 10 years ago. Thank you.
Okay, thank you.
Okay, so please go ahead.
Thank you. Thank you. Tao, so
Yes.
that's very interesting. When you're talking about the dog food eater, I think the ultimate consumer is the subscriber. So I think that's the common sense for all the people gathering here. So that's the reason I mentioned the question. Speaking of the legacy routines, are we on the right one? I'm talking about the imagination or the plan for the regular, say, terminals. I have several conversations with the China Mobile Research Institute. When we are talking about the 5G MBS, are we going to stick on the traditional routines? I mean, to develop the mobile phones equipped with the 5G MBS capability. So take the example for IMAX theater. So it's being developed well in the past 10 years or over 20 years. But the person, I mean the consumer, they are going to enter the theater, they are going to take the IMAX glass to view or to have the better experience in the theater. But we are not talking about the say widely used terminals. So I doubt, are we still working on the right track? I mean, if we are talking about the say special devices like the AR, the IMAX glasses, that could be an interesting topic. So the question is, are you going to, as the manufacturer for 5G terminals, are you going to have any plan on some say special devices rather than the mobile terminals? because with my point of view, I think that's, well, it's only the personal opinion. I think the special devices is not going to block the development for 5G MBS, but they will definitely improve the promotion for the consumers. That's the question. So are you going to?
Okay.
Yeah.
That is a long question.
Right.
Personally, I don't think we need those fancy commercial device and consumer devices to attract, to make 5G MBS a success. I don't think so. And to be honest, I don't understand what is the routine path we have taken during the past. So my view is to make 5G MBS a success. Maybe one thing we can do, as I've mentioned in my speech, is to is not to be too ambitious. We can be a bit down to earth more by embedding the 5G MBS capability into our network and make it invisible to the end user. Like we can try to enable this feature in our application layer. And in our first step, we are using this tool, this 3GPP tool, to save the operating cost, rather than to be too ambitious to imagine our scenarios, our techniques being used in those fancy devices. I think the first step in the first step we might be more conservative to make it invisible to our customer, and then if we found it useful, we found it valuable, we found it beneficial, we can then extend it to other scenarios like VR or XR or any other fancy use cases. Thank you.
Right. Well, I'm totally agree with you that we are not going to have some ambitious dream as we had in the past, but the key point is we really need to find the bottlenecks for the concrete need from the users either in the venue or online. So I agree with that. So we really need to see if any scenarios can fit the user either offline or online. But another interesting point is when you're talking about the online live broadcasting, that could be another a topic which I've been involved in WCC, which I've been co-chairing the team for web and networks, and as well as happened in the IETF. So these guys are talking about the online live broadcasting, but again, as the basis for these people from internet or TCP/IP, the logic for them is to utilize the internet to deliver the content as much as possible. But compared with the TCP/IP solution, I do believe in that the QoS guarantee or the utilize of the core network of telecom infrastructure could make us a better solution. That's the reason I mentioned that in my presentation. So I hopefully you can say we can continue the conversation in the future.
Yeah, of course. Yeah, I agree. People from internet and telecom, we have totally different mindsets on how to do the things. But for 5G MBS, I think there's one thing that might be our common ground, which is the IP multicast delivery. So if we can make something to make IP multicast can run in our network, maybe that is some common interests we can find a bit between us.
Yes, agree, totally agree. Just keep it real.
Okay, thank you.